We will see in this tutorial how to use graphical analysis to create a graph showing the evolution of the head loss of a fluid network section. Here is an inventory of the head losses of a section. We are therefore going to edit this section and test it on a range of flow rates to see its pressure drop curve. For this, we use graphical analysis. When we open the graphical analysis, the load loss inventory section is loaded. So you are ready to test the section over a range of flow rates from 0 to 100 cubic meters per hour. We launch the graphical analysis and we see the curves of the different types of loads. Here we see the divergent cone. Its pressure drops in pascals and in bars, depending on the flow rate range. When we leave the pointer over a graph, we get more information. Here the same thing, but with notions of energy, in watts and in kilowatts of power as. We can resize to highlight a graph. We therefore have here, below, the evolution of head losses as a function of flow. This graph is interesting because we see all the head losses of the section following the evolution of the flow. Here, in Pascal, we also have in this graph the power consumed according to the flow. We also see the annual cost of the loss of load. According to the parameters entered at the level of operating cost, the price per kilowatt hour, and the number of hours of operation per day. This gives a view of the cost of pressure drops, and it also allows us to reflect on the consequences of the economic choice of duct diameters that are too small, compared to the cost of operating this section in terms of pressure drop. We have the fourth graph here, which is the distribution of pressure drops by element, in the form of a pie chart, to highlight the proportions of pressure drops. Here, we see that it is the 10 sharp angle bends, which cause most of the pressure drops. You can save the images. You can change the scale, logarithmic or normal. It highlights the elements consuming the most pressure drops. We can have 3D effects to edit graphics and save the image. To make a load loss study file, so much for the graphical analysis and editing of pressure drop curves, depending on a given flow rate range. We will see in a next tutorial how to find the point of operation of pumps, fans or tank.